Hello everyone, we've got to the last question now, a proof by contradiction question on this paper 1 from 2024. So question 15 A, part 1, question 15 part 1 rather. Show that k squared minus 4k add 5 is positive for all real values of k. So this is just one of those things where we just need to complete the square and demonstrate that the coordinate of the turning point is a positive. So we just complete the square in the normal manner. We find when we do that the coordinate of the turning point, the vertex, is at 2, 1. So if the lowest point on the curve is at 2, 1, therefore it is always positive. And that's all you would be required to do for that first part. That's a super nice bit. The next bit, okay. A student was asked to prove by contradiction that there are no positive integers x and y such that 3x plus 2y times by 2x minus 5y equals 28. The start of the student's proof is shown below. So the student has assumed the contrapositive statement, the opposite. They've said, assume that positive integers exist, such x and y, such that that expression is true. So it says, show the calculations and statements needed to complete the proof. So they're not, notice, they're not insinuating that the student has made an error. Okay, the student has not made an error. And in fact, this statement here is the correct assumption. Okay, we're basically saying assume there are positive integers, x and y, such that that is the case. So that's all good. And the student started off by considering 14 and 2. And they found out that when you consider 14 and 2, you find out that you get non-integer solutions, okay? Now, at this point, sometimes students wonder, well, shouldn't the student also have considered 3x plus 2y is equal to 2 and 2x minus 5y is equal to 14? And the answer is no, you don't need to consider that as well. Because if you've done 14 and 2, if you swap round the 2 and 14, all you find is your solutions for x and y swap places, okay? So it's essentially the same system of equations, and they're not going to give you integer solutions, okay? So you don't need to do 14 and 2 and 2 and 14. It's sufficient just to do one pairing. So the student, in order to complete their proof, they need to think about what other possible combinations should they consider. They should consider 28 and 1 for a start, okay? Because the simultaneous equations might be like this. And when you do this, you get these two solutions, okay, which are also not integers. Remember, you would not need to also consider 1 and 28 because you're just going to get these answers but swapped over. So that's fine. So they are not integers. Okay, so they're not integers. So then they need to also consider 7 and 4. So we consider 7 and 4, and you solve those equations simultaneously, and you get these two solutions, which are also not integers. So basically, in all of the permissible combinations, every single solution is contradicting our original assumption that x and y are integers. Okay, so in every one that we're finding that x and y are not integers. So all of these cases contradict our original assumption that x and y are integers. So therefore, there are no positive integers such that 3x add 2y times by 2x minus 5y equals 28. And that's how you would be required to complete that proof by contradiction for 4 marks. I hope you found that helpful, and I will see you in the next paper.